In today's class, we are going to solve some more examples on normal distribution. In this next one, if the heights of 300 students are normally distributed with the mean 68 inches and standard deviation 3 inches, how many students have heights greater than 72 inches, less than or equal to 64 inches? Now, what is given by the data? We have mean and deviation, mu as 68 and the deviation as 3, and hence standard normal distribution is formula is z equal to x minus mu divided by sigma, that is x equal to this z equal to x minus 68 divided by 3. First one, if x is 72, then our z will be 72 minus 68 divided by 3. Just we have to substitute these values in this formula. So when you simplify, you will get 1.33. Then now we have to find probability of z greater than or equal to 1.33. So according to our formula, probability of z greater than 1.33, it can be written as probability of z greater than or equal to 0 minus probability of z less than 1.33, and this we have a standard value, that is a 0.5 minus from probability distribution table, probability of phi of 1.33 is what? 0.4082. When you subtract these two, we will get 0.0918. Therefore, number of students whose heights is greater than 72 inches will be, total number of students 300. So 300 into 0.0918, it will give us 28. So next one, if x is equal to 64, means less than or equal to 64 inches they have mentioned. So z will be, when you substitute, it means 64 minus 68 by 3, again minus 4 by 3, so minus 1.33. So we have to find probability of z less than or equal to minus 1.33. It is nothing but probability of this one. So it gives us probability of z greater than or equal to 0 minus probability of z less than or equal to 1.33. Again, this probability of z greater than or equal to 0 is 0.5 and probability of z less than 1.33 using our table is 0.4082. So when you simplify, you will get 0.0918. Therefore, number of students whose heights are less than or equal to 64 inches is 300 into 0.048 is 28 students. So next example, in an examination 7% of students score less than 35 marks and 89% of students score less than 60% of marks. Find the mean and standard deviation if the marks are normally distributed. It is given that probability of z between 0 to 1.2263 will be 0.39 and probability of z between 0 to 1.1475 will be 0.43. So in this, they are asked to find mean and standard deviation. We are given with the normal distributions of marks. So by the data, probability of x less than 35 means marks, the number of students who scores less than 35 marks will be 7%, means it will be 0.07, and probability of x less than 60, the number of students who scores less than 60 will be 89%, means 0.89. So normal distribution is what? Z equal to x minus mu by sigma. So when x is 35, z becomes 35 minus mu divided by sigma. We call this as z1. Now similarly, when you consider x as 60, then z will be 60 minus mu divided by sigma. We call that as some z2. Then hence we write probability of z less than z1 is 0.07 and probability of z less than z2 will be 0.89. So then probability of z less than z1, it can be written as probability of z less than or equal to 0 plus phi of z1. So 0.5 plus 0.5 z1 0.07, 0.5 plus 5 z2 0.89. We want phi of z1 and phi of z2. So take 0.5 to RHS, then subtract, we'll get minus 0.43 and 0.39. Using the given data in RHS, we write in the RHS, we are given with 0.43 will be minus 1.4757. So it will be phi of z1 is phi of minus 1.4757 and phi of z2 will be phi of 1.2263. Then z1 will be minus 1.4757, z2 will be 1.2263. That is, so substitute z1 and z2 in our equations. So that we'll get first equation for the inner z1, 35 minus mu divided by sigma will be is equal to minus 1.4757 and 60 minus mu by sigma is 1.2263. Cross multiply, then we'll get mu minus 1.4757 into sigma equal to 35 after cross multiplying. Similarly, here also cross multiply and take the mu to RHS. Then we'll get two simultaneous equations in terms of mu and sigma. After solving, we'll get mu as 48.65 and sigma is 9.25. Therefore, mean and standard deviation for this is 48.65 and 9.25. Next example. Assume that the reduction of a person's oxygen consumption during a period of transcendental meditation is a continuous random variable x, normally distributed with mean 37.6 cc per meter and standard deviation 4.6 cc per meter. Determine the probability that during a period of Tm, a person's oxygen consumption will be reduced by at least 45.5 cc per mt, at most 35 cc per mt, and anywhere from 30 to 40 cc per mt. So here we are given it mean and standard deviation. They are mentioned mean and standard deviation. So mean is 37.6 and standard deviation is 4.6 cc. So Z will be x minus mu by sigma is x minus 37.6 divided by 4.6. First one A, at least 44.5. So random variable be x 44.5. Then substitute in Z, you will get Z equal to 44.5 minus 37.6 divided by 4.6. After simplifying, we will get 1.5. So probability of x greater than or equal to 44.5 is nothing but probability of z greater than or equal to 1.5. It can be written as probability of z greater than or equal to 0 minus probability of z less than or equal to 1.5. Z greater than or equal to 0 is 0.5 minus z less than or equal to 5 is phi of 1.5. So phi of 1.5 is using your standard distribution table, you will get 0.4332. So after subtracting, we will get 0.068. The graph in the left side is showing the distribution. Z line, X line. This is a Z. this is red line is x, and here 0.5, and this is on x-axis, x line is 44.5. This shaded portion is our area covered. This is a part. Next, B is what? At most 35 cc per mt. So for x is 35.5, then z will be 35 minus 37.6 divided by 4.6. So when you simplify, you will get 5.5652. So probability of x less than or equal to 35 is given by probability of z less than or equal to 0 minus probability of z less than or equal to minus 0.5652. It is nothing but 0.5 minus 5 of 0.5652. 0.5 minus, in the standard distribution table we consider for 5 of, that is a 0.57. We'll round off that. In the 7th column value will be 0.2157. So lastly we get, after subtracting, 0.2843, the distribution. So this is the graph of distribution, normal distribution of a random variable and our normal distribution. The shaded portion shows us the area bounded. Next, somewhere it lies between 30 and 40. So Z1 will be considering x as 30 and Z2 will be considering x as 40. So substitute in normal distribution formula. So we'll get Z1 as minus 1.5652 and Z2 as 0.52173. So then probability of x lying between 30 to 40 will be probability of Z lying between minus 1.6521 and 0.52173. So this is nothing but 5 of 1.65 plus 5 of 1.52. Just directly use the normal distribution table. You have a standard values 0.4505, 0.1985. After adding, you will get 0.6490. So respective table, that's the graph, will be like this. This is the graph of z and x variables. Left side it is a minus 1.6521 and it is a 0.52173, respectively 30 and 40. The shaded portion gives us the area covered. So in the next class I am going to solve. This completes your module. Refer the textbooks. Some more examples are there, and in the assignment some more extra examples will be given. So in the next class I am going to start new module, that's a 4th module, statistical methods and curve fitting. Thank you.